Hi, a student from Phoenix, Arizona have contacted me and he's not able to get the answer for this differential equation. And he is choosing y equal to a e to power 3x. He is assuming this as a particular solution for non-homogeneous portion of this equation. And that's where he's making mistake. You know, if you notice that this, just by looking at the solution of that equation, we see that this portion is really the solution for the homogeneous portion of that equation. And this part is the solution for the non-homogeneous portion. So that means that this e to power 3x is a repeated solution. So this is a good example for a repeated solution case in higher order linear non-homogeneous differential equation. So what he should have assumed instead to solve this problem have been ax e to power 3x. So anytime we have a repeated solution, we have to multiply that by x and assume that as the particular solution for the non-homogeneous part. So this is his mistake. This is what you have to assume as a particular solution for that non-homogeneous equation. Otherwise, this is a very simple equation. So let's go ahead and solve it now that we are here. We know that the solution for this type of equation can be written as yc plus yp, where yc is the solution to the corresponding homogeneous portion of this equation, and yp is the solution to the non-homogeneous portion of this equation. So to find yc, let's use the auxiliary polynomial and write this portion as m squared minus 3m equal to 0. Then we factor m out, m times m minus 3 equal to 0. So from this equation, m will be equal to 0 and m will be equal to 3. So yc, the solution to the non-homogeneous, the solution to the homogeneous portion will be equal to c1 e to power 0x plus c2 e to power 3x. So e to power 0 is 1, so yc will be equal to c1 plus c2 e to power 3x. So this is really yc right there. Now we need to find yp. So to find yp, we have to assume yp equal to ax e to power 3x. We have to put y because we have a repeated solution here and here. So we have to assume ax e to power 3x, so dy over dx will be equal to derivative of x, which is a multiplied 3x plus derivative of the second one multiplied, so plus 3a x e to power 3x, and d2y, the x2 is equal to 3a e to power 3x plus 3a e to power 3x plus 9 8x e to power 3x. So this is the d2 dx. Now if we plug those values in this equation, we are going to have d2y dx2, which is 3a e to power 3x plus, so this will be 6a e to power 3x, 3a e to power, so this is 6a e to power 3x plus 9 8x e to power 3x minus 3 multiplied by that, so minus 3 8 e to power 3x and minus 9 8x e to power 3x. Okay, is equal to 2 e to power 3x. So from here, these two will cancel out, plus 9a e to power 3x minus 9a e to power 3x, and we are going to have 3a e to power 3x equal to 2 e to power 3x. So if we divide both sides of the equation by e to power 3x, they will cancel out. So we are going to have 3a equal to 2. So a will be equal to 2 divided by 3. So our particular solution for the non-homogeneous portion is going to be equal to 2/3 x e to power 3x. So our general solution will be yc, which was that, plus that, which is that. And the mistakes are like this are very important. You have to be careful, even though the problem is a simple problem, but one small mistake would make a difference between A and B